today, and isotopes are atoms of the same element with different numbers of neutrons. So they're similar to different versions of the same element. Let me try and describe isotopes to you using this illustration. Let's say we have this particular make of cars called a Fishmobile, and it just came out. It's brand new. Everybody wants it. And there's 3 different versions of the Fishmobile. There's the Fishmobile G, the Fishmobile GX, and the Fishmobile GXL. The Fishmobile G doesn't have a lot of the same fancy features like the GXL has. The GXL has some features like, I don't know, heated butt seats. Aren't those the best? Roll down electric windows. The fancy, touch the door and it unlocks, has all these fancy features. The GX has leather seats but doesn't have a lot of those fancy features. And the G really is just your basic model. Now, they all have different features. They're all different variations, but ultimately they're all the same make. They're all the Fishmobile. They're all the same model of car. So that's kind of what I want you to keep this picture in mind when we're talking about isotopes. Isotopes are different variations of the same element. So think of this element, carbon. Carbon has 6 protons, and we know that because its atomic number is 6. And the atomic number always tells us the number of protons. The number of protons is the distinctive property for an element. It tells us how many protons they have. Even though other things about carbon atoms may differ, the one thing that will never differ for every single carbon atom is their atomic number. Let me show you an example. Here are 3 different carbon atoms. And how do I know they're carbon? Well, remember, carbon has an atomic number of 6, so every single carbon atom has to have 6 protons. So how do we know these are carbon atoms? Well, if I look at this atom, the protons are orange, and I count them. 1, 2, 3, 4, 5, 6 protons. That means this is a carbon atom. 1, 2, 3, 4, 5, 6 protons. That means this is a carbon atom. 1, 2, 3, 4, 5, 6. 6 protons. This is another carbon atom. Now, these are not all the exact same type of carbon atom because there is something else that is changing in this carbon atom. I took off the electrons because we're not going to focus on electrons right now, but I want you to focus on the number of neutrons because the number of neutrons for each of these is slightly different. This atom has 1, 2, 3, 4, 5, 6 neutrons. Neutrons are the black dots, so I just wrote 6 here. This carbon atom has 1, 2, 3, 4, 5, 6, 7 neutrons, and then this carbon atom has 8 neutrons. Now, what does that mean exactly? Well, what that means is that these carbon atoms are all carbon atoms because they have 6 protons. That is what makes them a carbon atom. But what makes them different is their number of neutrons. So what does that actually affect? Well, we know that neutrons don't have a charge, so the differing numbers of neutrons won't affect the charge of the carbon. What it does affect, though, is the mass number. Remember, the mass number is when we have the protons plus the neutrons. So this carbon has 6 protons plus 6 neutrons, which makes it have a mass number of 12. So the way I would write this particular type of carbon atom is to write it carbon 12. That's kind of similar to when we were talking about the different Fishmobiles, how we would characterize them by having a G or a GX or a GXL. Well, when we're talking about atoms, we categorize the differences between the carbons by doing a dash and then put the number there for the mass number. So this carbon we would call carbon 13 because it has a mass number of 13. This carbon we would call carbon 14 because it has a mass number of 14. Isotope. An isotope is just an atom of the same element, just like we saw before, but with different numbers of neutrons. So think of an isotope as being different versions of the same element. How do we write an isotope? This is what's called isotope notation. Isotope notation is just when you put the symbol of the atom right here, the atomic number of the element goes on the bottom left-hand corner, the charge of the element goes in the top right-hand corner, and the mass number goes on the top left-hand corner. So when we look at the atomic number, we can figure out what symbol it is. That tells us the number of protons. The charge will only change if the numbers of electrons change in an atom. The way you figure out which isotope of the element it is through the mass number, because the mass number will tell you that this is iodine 131. Here are some different ways you can write an isotope notation. If you have a carbon atom that has a mass number of 12, then you can write on the isotope as being carbon 12. Another way you can write it is put the C here, and on the bottom left hand you have the atomic number, and the top left hand you have the mass number. Another way you can write it is by including the charge. When we were trying to figure out how to write the isotope notation for calcium, all we have to do is add together the protons and the neutrons to get the mass number, and we would write it as calcium 48, because 48 is the mass number. You can also write the isotope notation using the symbol, the atomic number on the bottom, and the mass number on the top left. What would we call these 6 different atoms? Well, we would call these 6 different isotopes of the element calcium. Alright, if I give you an element, and I give you the number of protons in that element, the number of neutrons in that element, and the number of electrons in that element, you should be able to figure out the name of the element and the isotope, the chemical symbol, the atomic number, and the mass number. Let's start by looking, if we have 44 protons in this atom, we can automatically figure out the element that it is, because the protons and the atomic number are always the same thing. So if we have 44 protons, we have an atomic number of 44. When we look on the periodic table, number 44 is ruthenium. So we know that this atom is ruthenium. Now what can we do? Well, let's look at the mass number. The mass number is when you add together your protons plus your neutrons. So if I have 44 protons and 56 neutrons, my mass number is 100. Now that I have my mass number, I can write down the isotope name. The isotope name is ruthenium-100. Now to figure out my chemical symbol, I know my chemical symbol is Ru just because I looked on the element, the periodic table of elements. But what happens if ruthenium has a charge? How would I know if ruthenium has a charge? The only way you can know is by looking at your number of protons and your number of electrons. In order for this to not have a charge, the number of protons and the number of electrons have to be equal. But they're not equal. I actually have 4 more protons than electrons. Remember, protons have a positive charge, so I have 4 more positives than I do have negatives. So I write the chemical symbol for ruthenium by writing Ru4+. In this example, I'm giving you the mass number and the chemical symbol. The chemical symbol says Na. So I look on the periodic table, and I see Na stands for sodium. Sodium has an atomic number of 11. So I can automatically fill in that the atomic number for this element is 11. If 11 is the atomic number, I automatically know the number of protons, because the atomic number equals the number of protons. So we have 11 protons. If I have the mass number, I can go ahead and write out the isotope name. The isotope name is the name of the element dash the mass number. So sodium-22 is this isotope. To figure out the number of neutrons, I just have to take the mass number, subtract my number of protons to find the neutrons. Because remember, mass number is the number of protons plus the number of neutrons. To figure out my number of electrons, I have to look at my charge. Since I have a +1 charge for sodium, that means that it has 1 more proton than it has electrons. We have 11 protons. That means we must have 10 electrons, so we have 1 more proton to give it that positive charge. Alright, I want to make one last point before we go today, a little clarification point. And the things that I want to clarify are what happens when we change things. We've talked a lot about changing electrons. When you're changing electrons, all you do is you change the charge of the atom. You don't change the atom into a different element, you're just changing the charge. Remember, when we change charge, we call that an ion, when it gains a charge, when it's either positive or negative. If you gain more electrons, then you become a more negative ion. If you lose electrons, you'll become a more positive ion. When you change the number of neutrons, that also doesn't change the element. That just changes the mass number. We call those isotopes. Isotopes are just different versions of the same element. They have different numbers of neutrons, but they're still the same element. proton numbers, think of them as being permanent because proton numbers stay the same for every atom of that element. And that's it for today.